This is a more complicated rational function. You can see it's got four sort of factors involved. Also, the degree of the numerator is equal to the degree of the denominator, which we haven't seen so much. So I'm going to show you how to graph something like this. Here's a sign chart that has 3 and 2 and -1 and -2. The -2 comes from the 2x plus 4 factor. It's the numerator is when the numerator is 0, the whole thing is 0. When the denominator is 0, it's undefined. And we'll see in the next video that it doesn't always quite work this way, but it usually alternates, starting with a plus at the far right and alternating plus minus, plus minus. I find it useful to pop 0 into the equation and get 4 times -3 is -12 over -2 is 6. And I'll start graphing. Here's the 6 is kind of up here. I'll make this is going to be 2, 4, 6, 8. We have these zeros at -2 and at +3. We also have asymptotes. I'll make those green at -1 and at +2. And really useful is when you see a U, the behavior to the left and right of it. So a U with a minus on the left of it is an arrow like that. A U with a plus to the right of it is an arrow like that. This U has a plus to the right of it, so this happens, and a minus to the left of it, so that happens. So we have a lot of stuff here. But what we don't have is the horizontal asymptote. And I'll show you the trick for that. In this one, the degrees are equal. If the degree of the numerator is less than the degree of the denominator, there's a horizontal asymptote on the x-axis. I'm just going to write down that this is approximately 2x squared over x squared, like if I multiplied it out, which is approximately 2 over 1. So with this we get a new rule. And the rule is that if you ever have rational expression where, let's just say there's just a bunch of stuff here and down here, these are equal, the degrees are both degree 5. When that happens, these things you could ignore, and the answer is just going to be the ratio, a horizontal line, y equals 3/4 is going to be the horizontal asymptote. It's the ratio of the coefficients of the largest power. This is when there's a tie in the degrees, which has happened here. So this one has a horizontal asymptote at y equals 2. Now, seems like this has to happen. And there's a bit of an issue going on here that was a lot easier when the horizontal asymptote was at y equals 0. Because we know that there's this asymptote, this horizontal asymptote, and we know that the graph is positive for large values. But what we don't really know for sure, it seems like this probably happens. But it is also possible, and would not contradict this, if this somehow went through the axis and came back down, because that would still be a plus here. So we're not really sure. We have to do one extra calculation to be sure. And the extra calculation is, since we know that the asymptote's at y equals 2, if we set our original equation 2x plus 4 over x minus 3 over x plus 1 x minus 2. If we set it equal to 2 and try to solve that, that's going to take a lot of work actually. Equals 2, sorry. I'd have to multiply out the numerator. 2x squared minus 6x plus 4x is minus 2x minus 12 over x squared minus x minus 2. Then you'd have to cross multiply. We'd end up with 2x squared minus 2x minus 24. Now in this case we get kind of lucky in that these cancel out and these cancel out, so there's no solution. And that means that it does not cross the asymptote. But if this equation worked out that there actually was an answer, that would mean that it sort of, whatever, let's say the answer was at 6, it would mean that this would happen. But it's not what happened here. But it is useful. You really can't be sure unless you check. Okay, the other type of question I wanted to show you is when there's 2 factors in the numerator and only 1 in the denominator. So the degree of the numerator is higher than the degree of the denominator. Here's my sign chart. At minus 2 it's undefined. At minus 4 it's 0. And at 1 it's also 0. Plus, minus, plus, minus. So I have the asymptote at minus 2. I have x-intercept at 1 and minus 4. And I find it really useful to do around the u. A u with a plus on the left goes like that, and a u with a minus on the right goes like that. And also useful is to plug 0 in, and you get 0, negative 1 times 4 is negative 4 over 2 is negative 2. That doesn't, you can't get that off of the sign chart. So I have, it's not very promising here. I have some stuff, but I don't really know what to do at this point. So here's a new thing now. When the degree of the numerator is bigger than the degree of the denominator, it's not going to have a horizontal asymptote. Instead, it's going to have something called, if the degree is 1 higher, which it is in this case, this numerator is degree 2, this is degree 1, it's going to have something called a slant asymptote, which is going to be a line, but it's not going to be a horizontal line. And the way we figure out what it is we divide the denominator into the numerator after you multiply the numerator out. So x squared plus 3x minus 4. And you divide, you get x squared plus 2x. You subtract, you get x minus 4. X times 1, so plus 1 is x plus 2. And we end up with our answer, we get remainder negative 6. So the original question could be written as x plus 1 minus 6 over x plus 2. Now for our purposes, that x plus 1 is the slant asymptote, which we graph by going over here, whoops, make it green, and the slope is 1. Now, extra information that's also useful is this minus sign here. Because this is a minus sign here, it means that as I get really big, I'm very close to x plus 1, but because this is minus, I'm always under it, so I can make my arrow going like that. But if you put a big negative number in, minus 6 over x plus 2 becomes a positive, very small number, so it's above for negatives. And then I just connect these as best as I can. And what we end up with, it's like a hyperbola, but a hyperbola where the asymptotes are not perpendicular to each other. And in questions like this, sometimes we get pictures that look like this, and sometimes, I'll just use a different color, sometimes we get pictures that look like this. It's almost like which quadrants am I in? Am I in quadrants sort of 1 and 3 or quadrants 2 and 4? Anyway, this question was using the red, not the blue. I just wanted to show you that was a possibility. And that does it for today.